Okay, so this is just first off, this is the release questions from the 2009 test. So this is one of the non-calculator free response questions. So this would normally be scored out of 9 points. And in fact, each of the 3 parts of this one are worth 3 points each. Not always the case. Sometimes some of them are worth more than the others, but in this one, each is worth 3. So first part is finding the area of R. And since we're given 2x and x squared, we can clearly see that for every x value from 0 to 2, the linear function is above the parabolic function. And so all we need to do is integrate from 0 to 2, the upper function minus the lower function. And that's part A. And if you wrote this out properly, that was worth 1 point out of the 3 that you could have got for part A. Then the second point would have been for properly integrating. So x squared minus x cubed over 3. And writing that you evaluated that from 0 to 2. So this is 1 point. This is 1 point. And then getting your final answer, which you should have gotten 4 minus 8/3 minus 0 minus 0, which ends up giving you a final answer of 4/3. That was your third point. Easy enough for part A?
If I did it.
So
you can go.
Okay, so if we forgot the dx, would we lose a point? If we forgot our dx.
I have seen instances where they do give people the points if they forgot the dx, but I think it's sometimes subjective to who's grading your exam because, I mean, think about it, you got hundreds of different people in a room, and some of them are going to be more of a stickler than others are. So just make sure you don't forget the dx. But I would say chances are if you forgot the dx, you got a 50-50 shot of them giving you that first point. They'd still give you the other 2 points, so you could still get 2 out of 3 on it, but yeah. All right, everybody good there with part A?
I did it. I have one just question kind of thing. I did it right to left because that seemed most obvious to me because it seemed like the parabolic was always to the right of the linear, and I got the same answer, 4/3 units squared. Would I still get full credit there or no?
Yep, should be fine. Okay. This is just what they're, I mean, this is how they would expect you to do it. This is what their scoring guide would have listed, or what it does have listed for this problem. But that doesn't mean that they don't give alternate methods to the graders to look at. And keep in mind that all the people that are grading this are AP Calculus teachers, so they all know how to do calculus theoretically. But I mean, if it's all given to you in terms of x, normally try to keep it in x if you can. But yeah, you would have gotten 3 out of 3. That's fine. Okay, so for part B, it then says that we've got now a solid that has this region as its base, and that the cross sections perpendicular to the x-axis have this area. So it doesn't say what shape they are, but it gives us a formula for the area. So all we should need to do then is just integrate that area times the thickness of each of those cross sections, and those cross sections will be in terms of x, dx cross sections. And so we'll just go in and integrate from 0 to 2 this area function times dx. So for part B, should look like an integral from 0 to 2 of the sine of pi over 2x dx. And in order to do that integral, Hopefully you can do that integral without writing out the u substitution, but if you need to, that's fine. You're going to let u equal pi over 2x with du equaling pi over 2 dx. So you'd have to put in a pi over 2 and a 2 over pi out in the front. And you'd end up then with 2 over 2 pi, the 2 over pi, times the integral of sine of u du. And instead of going from 0 to 2, you'd now go from 0 to pi. You'd integrate, which would give you a negative, and with the 2 over pi cosine u from 0 to pi. And on the scoring guide, they actually don't write out the u substitution. They just assume that you can go from the integral of sine pi over 2x dx to negative 2 over pi cosine u from 0 to pi. But if you write out the u substitution and do it this way, that's fine also. And then you just need to evaluate. So negative 2 over pi cosine pi minus negative 2 over pi cosine of 0. And cosine of pi is negative 1, so that becomes a positive 2 over pi. And this is minus a negative, which makes it plus. Cosine of 0 is 1, so plus another 2 over pi, which would give you 4 over pi. And points for this one were 1 point for having the correct setup. You didn't need, just for writing integral 0 to 2 sine pi over 2x dx was 1 point. Second point was for getting the correct antiderivative, and then the third point was for getting 4 over 5.
Do they not care about units at all?
They do not need you to write units squared or units cubed on these. It's a good habit to be in. Some calc professors will want you to do that, but and I prefer you to do it, but they don't require you to on the AP test, unless it specifically says, like, if it gives units to it, and then you need to put the units. Usually, if there's a point associated for having units on it in the question, it will write something like indicate units of measure. So, everybody go to part B. Any questions on part B? All right, so now we've got part C, which has another solid, has the same base, but now the cross sections, which are perpendicular to the y-axis, are squares. And we need to write, but we don't necessarily need to evaluate, an integral expression for the volume of that solid. So part C, we're still looking at the same region here, right? But the cross sections perpendicular to the y-axis are squares. So we've got squares sticking up out of this perpendicular to the y-axis. And so we know that the area of a square should just be the side length squared. And what we need to do is we need to figure out what's the length of one of those sides in terms of y. And we have to do it in terms of y because those are perpendicular to the y-axis, which means they have a thickness of dy. And our original picture had given us the value of this point as 2, 4. So we're going to integrate from 0 to 4. And it should be whatever the side length squared is. Well, our side length is the rightmost function, which is the parabola, minus the leftmost function, which is the line. And our parabola was, what was it? Was it a y equals x squared? And the other one was y equals 2x, I believe.
Yeah.
Okay. And so this gives us x equals the square root of y, and this gives us x equals y over 2. And so the parabola ends up being the square root of y, and the line ends up being y over 2. side length squared gives us our area of each cross section and a dy. And so for this one, they gave you 1 point for having the correct limits, 0 and 4, and then 2 points for having root y minus y over 2 squared dy as your integrand. How'd that go? Everybody feel okay about that one?
Yep.
Did many of you get all 9 points?
Just missed a few.
Just missed a few. Yeah, so generally, I mean, obviously you want to try and get 9 out of 9 on all of the free response, but what I generally tell people is that if you get 6 out of 9 or better on all the free response, you are in very good shape to be sort of right there between getting a 4 and a 5 on the AP test. So if you get 6 out of 9 on all of them, you're in pretty good shape to get a 5, as long as you can do pretty well on the multiple choice. Let's see, Riley, would it be okay if you simplified the root y minus y over 2 squared? Yeah, I mean, that's fine if you wrote it out as y minus 2y to the 3, or minus y to the 3 halves plus y squared over 4. But don't do unnecessary work. Don't simplify things more than are necessary, especially if it says write but don't evaluate something. You know, no reason to bother doing that. It's okay if you did. It just gives you a chance to make an algebra mistake, though, that they'll then take points away from you for. So. Any other questions on that one? A, B, or C? All right, let's do another one. So this one's got some cross sections and it's got some solid of revolution. Pretty similar to the last one. This one again, and that one we just did, I would say, is on the easier range of what you might see in terms of area and volume problems on the AP test, and certainly on the easier range of free response questions. So don't get too excited if you did really well on that one. There's still a lot of work to do. But all right, next one here. I will give you guys another 15 minutes. Was 15 minutes good, or were you guys just sitting around doing nothing for a while?
No, I think that was a reasonable amount of time.
All right, then another 15 minutes here for this one, and then we'll go over it. Ready, go. So for part C, since I forgot to start recording for A and B, part C says we're going to revolve this around the line y equals 2. So if we're revolving around the line y equals 2, we're still going to be able to do this in terms of x. So try and keep it in terms of x if we can, since everything's already in terms of x. We just need to find our outer radius, which will be the distance from 2 to this function, and we need to find our inner radius, which will be the distance from 2 to our square root function. And so the distance from 2 to the x over 2 function is just 2 minus x over 2, and the smaller distance, the inner radius, is 2 minus root x. And so our formula for finding that volume should be pi times the integral from 0 to 4 of the outer radius. So that was 2 minus x over 2 squared minus the inner radius, 2 minus root x squared dx. And as 1 point was given if you had a pi out in front and a 0 and a 4, and 2 points for all of this. So 3 points for that one as well. Any questions on that one? And just real quickly, since I forgot to record, we'll just go back. Finding the area of R for part A is just the upper function minus the lower function. So upper function was root x, lower function is x over 2. They gave you the points of intersection of 0 and 4 already, so you just integrated 1 point for having the correct setup, 1 point for the right integral, and 1 point for evaluating it correctly. And for part B, it said that the cross sections were squares perpendicular to the x-axis. So we drew these little squares in here and said that the side length of one of those squares was the upper function minus the lower function, root x minus x over 2. And since the area of a square is side squared, we did root x minus x over 2 squared, integrated from 0 to 4, distributed it out to get this, integrated it to get this, which was your second point. So 1 point for the correct setup, 1 point for this integral, and 1 point for evaluating it properly. So hopefully that's good now on parts A and B, since I forgot to record those. Anybody have any questions on this problem at all? All right, we've got one more here. Would you guys prefer to just sort of go through this one together? Or would you prefer to have the rest of the period to work on it and then talk about it tomorrow?
Rest of the period to work on it.
All right, and probably better if you guys do it later. So, all right, so you can work on this one now. We will go over this one first thing tomorrow before the quiz, and then I'll take any other questions before the quiz, and then we'll have the quiz tomorrow. So don't leave putting 12 minutes on the timer now, because that's when this class gets out, and you will do this problem and we will talk about it tomorrow. Ready? Go.
Is the quiz going to be very similar to this?
Yeah, I mean, the problems will be volume problems. There won't be any area problems, but yeah, I don't think anything is going to be exceptionally difficult.
Okay.
Just want to test whether you understand it. You can see that, I mean, sometimes they put some more difficult ones in here, but most of them are fairly straightforward with the area and volume problems.